In this video, I'm going to determine the formula for the sinusoid that models the daylight data. Here is the given data. In order to determine the equation for the hours of daylight, h of t as a function of the day of the year, t, where t is counted as the number of days after December 31st, we must first find the parameters. Looking at the data, we see that the most amount of daylight during the year is 15.27 hours, and the shortest amount of daylight is 9.07 hours. The values 9.07 and 15.27 represent the minimum and maximum amount of hours of daylight per day during the year. By averaging the maximum and minimum values, we get 12.17, which represents the average amount of hours of daylight. This value of 12.17 also gives us the k-value or midline, y equals 12.17. Next, we find the amplitude by finding the distance between the midline and each of the maximum and minimum values. The distance from both the maximum and minimum to the midline is 3.1, which gives us an amplitude of 3.1. To find the b value of this function, we use 2 pi over the period. Our period value would be 365 because 1 year has 365 days, so our b value is 2 pi over 365. Because we are starting at t, where t is counted as the number of days after December 31st, the graph has a horizontal shift to the left of 10 because the minimum of the data is 9.07, which takes place on December 21st. And December 21st is 10 days before December 31st, so h would be equal to negative 10. After finding all these parameters, we are finally ready to determine our equation. So using the basic equation, h of t equals a cosine b of t minus h plus k, we can use our parameters to fill in this equation. Since it's starting in the beginning of winter when the hours of daylight are the fewest, we would start from the minimum, making the cosine function negative. After plugging all the values in, we get this equation. H of t equals negative 3.1 cosine 2 pi over 365 of t plus 10 plus 12.17. This is the sinusoid for the function that models the daylight data.